Hello, welcome viewers. Now I will try to give you a brief introduction to the course which involves the cutting of spur and helical gears. You know, gears are very much essential for different engineering applications and different social and household applications, and they are used for speed change, they are used for power transmission from one place to another place, and they are used for converting linear motion to rotational motion and vice versa. There are so many applications of gears. How do we cut these gears? So, gears can be made different in different manner. I mean different types of procedures are present for cutting gears. For example, you can actually machine it, that means cut it out of a piece of material which is called a blank, and this cutting process might be involving heavy machine tools. Okay. There can be milling of gears, there can be broaching of gears, you can even carry out what you call it wire cut EDM, you can carry out CNC machining, or you can use dedicated machines like gear hobbing, gear shaping, etc. These have their respective fields of application, that means they are suitable for different types of applications. But first of all, I should mention that not only machining or cutting, there are other ways also present of existing which can produce gears, not only machining. For example, you can cast a gear, you can form a gear, you can rapidly prototype a gear, and you can produce it by powder metallurgy. So many methods are there. Why is machining important? Because machining in general gives high accuracy, good surface finish, it can be automated, it can be made applicable to large scale, that means mass production. It can also be made applicable to small lot and batch production, single piece production, as the case may be. For example, you can have dedicated machines like gear hobbing, gear shaping, which are good for medium to high level production. You can set up a milling machine for cutting out spur and helical gears for single piece production, for small lot production, etc. You can have CNC machines which can deal with small lot and batch production, etc. You can have wire cut EDM, which is good for cutting out materials from cutting out gears from conducting materials. Of course, for helical gears wire cut EDM is not suitable. So, in different cases you can have the application of different methods of cutting, which makes it very convenient for us and economic also to have gears made by different ways. And we are going to study in detail some of these methods which are existing, for example, by milling, gear cutting by milling, gear cutting by gear hobbing, and gear cutting by gear shaping. Before this detailed lecture on the definite processes, we are going to have a discussion of gear tooth nomenclature, then what do you call it, some simple calculations involving gear geometry, some simple calculations for finding out gear ratios, etc., which will be useful for us in finding out or setting up a machine. During setting up of a machine, it means that suppose you decide that you will be cutting a gear of a particular module and with a particular number of teeth, with a particular helix angle. In that case, a gearbox, a machine tool might be possessing a number of gearboxes which have to be set up with a particular value. So, those things also we are going to discuss. We are also going to discuss the kinematic structure of a machine which makes it possible for us to cut a gear with some with some advantages. For example, if I want to cut a gear with say 20 teeth, the next moment after it is finished, I want to cut the gear with same specifications with the number of teeth to be different, like 200 teeth, okay, module remaining the same, helix angle remaining the same. In that case, what do I do? How do I proceed? So, in that case, the positioning or positioning of the gearboxes, configuring the machine becomes a very important aspect, which we are going to discuss, especially with gear hobbing, gear shaping, etc., etc. We are also going to discuss the comparative comparative study of the processes as regards accuracy, productivity, scale of production, etc., etc. So, in totality it will be study about gear geometry in a very preliminary level and gear calculations, positioning of gearboxes in a kinematic structure, then study of specific methods like milling, then gear hobbing, gear shaping, etc. And last of all, we will also have a discussion on the testing and metrology of gear inspection and measurement. Thank you.